In this video, we're going to explore measures of position. First measure of position will explore our z-scores, and they can help us look at data that's unusual when our data is symmetric and bell-shaped. And what a z-score looks at is how many standard deviations a given value is from the mean. So to do this, we need to know the mean, the standard deviation, and the value we're looking at. So say in this example that our mean is 70 miles per hour and we have a standard deviation of 5 miles per hour of people driving on I-40, and we want to pull over anybody that's going 2 or more standard deviations above or below the mean. So first we need to recognize what is our mean standard deviation, which are given to us, and now we're going to test each of these values. So car 1, they're going 73 miles per hour. When I plug in the formula, their standard deviation is 0.6 of one standard deviation away from the mean. So that means it's just a little bit above the mean. They're okay. Car 2, when I plug in 80, and I plug in the formula, 80 minus 70 divided by 5, they're 2 standard deviations above the mean. And I know it's above because that z-score is positive. Since it's 2 standard deviations from the mean, they'd get pulled over. Now the last car is 57, so they're going slower, but remember, we can go below this standard deviation as well. In this case, they go negative 2.6 standard deviations below the mean. Again, it may be negative, but it's more than 2 standard deviations from the mean, so they get pulled over. Now, as you can tell with these data, that's pretty far away when we start getting that many standard deviations away, and those types of outliers can influence our data, can influence the mean, the standard deviation, and the scale of our histograms. So as you can see with this type of data here, where a lot of our data is between the values of 1 and 6, and there's this one entry that's way out there at 22. So when this occurs, we start to use alternative measures such as box and whisker in the 5-number summary. And what they use are called quartiles. And a quartile takes the data and splits into 4 equal parts based on positioning. So at the Q1 and Q3, Q1, Q2, and Q3 are all looking at medians of different parts of the data. Q2 is the most recognized one because that's the median of our entire data set, whereas Q1 looks at the first half of the data's median, and Q3 looks at the second half's median. And we'll talk about the interquartile range, which is the difference of Q1 and Q3. So say that I was looking at number of customers during the 8 to 9 a.m. during the last 15 weeks. If I wanted to find these 3 pieces, the first thing I always find is my overall median, Q2. The next, I'd say that tells me how to split my data. So I get my lower half and my upper half. Now I find my lower Q1, so I find the median of this set, which would be 10. Then I find the median of my upper half, which would be 18. And if I want my IQR, I would take 18, subtract 10, and it would be 8. Now when I go to find the 5-number summary, I'm often going to use this when my data is skewed due to outliers. And the 5 numbers it represents are the minimum value of my data set, my quartiles 1, 2, and 3, and then the maximum value of my data. First thing I always have to do is order my data from smallest to greatest. And if I'm using Excel, I'm going to start in the very first row, A1 or B1, whichever you're using. From there, I've got my data sorted. I know very easily what is my minimum and maximum values because it's going to be the very first and the very last values. Next, I want to find my overall median, Q2. And I also want to find its location so that I can get an idea of where my split is in the data for the first half and second half for my Q1 and Q3. So I'm going to use the median formula to find my Q2. To find the location, I take the number of entries plus 1 divided by 2. And that's important, especially when I start talking about whether I have even or odd number of data entries. And then my Q1, I'll use the median formula with the upper half. Q3 will use my median with the lower half. So let's look at an example, both an odd and an even set. So here's those 15 numbers that we had before. If I highlight them all, first thing I want to do is I want to order my data. So I go home, and then I go sort and filter smallest to largest. That makes it very easy for me to know that my minimum value is 5, my maximum value is 37. And again, you see I started in A1. Makes life a lot easier. Next thing I find is my Q2. So I do median, and I'm going to highlight all my data, and it tells me 15. Now in this case, that's pretty easy because there's only one 15 in my data set, but I always want to double check that location. So I know there were 15 pieces of information, 15 values I looked at, plus 1 divided by 2. So that would tell me it's the 8th entry, which that would line up with A8. So everything's good. Now that helps me know that this is my upper half, which I'd use with Q1. So I do median, and then just select the first 7 values. And then for Q3, I'd use median with my lower 7 values. And there would be my 5-number summary. And that's going to be necessary when we do the box and whisker plot. Now with the even, first thing again, home, sort and filter smallest to largest. Again, I know my maximum value and I know my minimum value, or vice versa. And I want to find my median at Q2 first as well. Just highlight all my data, and that'll tell me the value. Now when I see a half, that often tells me it's in between 2 values, which is going to happen whenever I have even number of information. In this case, to find that location, I know there's 16 pieces of data plus 1 divided by 2. And by being 8.5, that tells me it's in between the 8th and 9th pieces of information. That's important. So what I do here is I say something like creates Q2 creates Q2. And it's not that these are Q2, but they help create it. That means this is actually cells 1 through 8 are what I'm going to use for my first quartile. So whenever I have an even set, all my data points are actually going to be used to help me find my quartiles. In this case, I'd go 9 through 16. So it's very important when the even sets that I pay attention to my Q1 and my Q3 especially. So as I mentioned, the 5-number summary, we use that to help us find the box and whisker plot. So we take those 5 numbers, and I'm going to plot them on a horizontal number scale, and then I'm going to draw a box around my Q1, Q2, and Q3, and then draw whiskers out to my maximum minimum values. So if I took that 15-week example, again I have my max, my min, my Q1, Q2, and Q3, and I'm going to plot them on a horizontal number line. I'm going to draw boxes around Q1, Q2, and Q3, and draw whiskers out to the ends. And if I wanted my interquartile range, again, that'd be Q3 minus Q1. Other types of splits that I may have, we have quartiles. A quartile is a type of fractile, and these are numbers that divide sets into equal parts. So other than quartile, which is 4 parts, you may see decile, which is 10 equal parts, and percentile, which splits our data into 100 equal parts. And that's the most other likely one you will see, is percentiles. So let's look at a quick example. Say that the graph on the right represents the cumulative frequency distribution for scores in the SAT, and about what score represents the 90th percentile, and how would you represent this? So here's my percentiles, here's 90, so I'd want to come over, and then if I want the SAT score, I'd go straight down. If I look, it goes right to this value here, which is about 1900. So what that means is that about 90% of students scored 1900 or less on the SAT, because the percentile is always that value and less.